So last time we talked about being able to solve quadratic equations with a square root. And so we looked at problems like what I have up on the board here. X squared equals 16, we can solve with the square root. X plus 1 as a quantity, right, in parentheses squared equals 7, we could solve with the square root. The big idea was we got a squared thing by itself, and then we took a square root on both sides, and that was our strategy to be able to solve, right? That was what we looked at right after solving by graphing. So today we're going to continue to look at using square roots to solve, but this time we're going to start with stuff that isn't set up like these examples up on the board, okay? So if we take a look at the first example that we have on page 7, x squared plus 10x minus 3. The way that this is written right now, if this were a couple of days from now, I would think to myself, well, maybe I could solve by factoring. We haven't done that yet, but in a few days, that's what we're going to talk about, solving by factoring. But if I tried that here, factors of -3, that would add to 10. Well, I've got -1 times 3, or I've got 1 times -3, and neither of those add to 10. So we haven't talked about solving by factoring yet, but even when we do, this is not something I could factor. We saw a couple problems like that in our last unit, so I couldn't solve this by factoring. We need another option. What we're going to do today is take a look at how we can solve something like this using square roots. Now, as this is currently written, I could not solve it with square roots, and we're going to take a look at why. So last time, we said to solve something using square roots, we have to get the squared thing by itself. So here that would mean this x squared term. So let's go ahead and do that. We would have to move this 10x to the other side and the 3. So minus 10x plus 3. We would get x squared equals -10x plus 3. And now the squared thing's by itself, so we could take a square root on both sides. And we would get x equals plus or minus the square root of -10x plus 3. What's the issue here? Why does this not work as a solution? X equals plus or minus the square root of -10x plus 3. Yeah, I'm saying x equals something with an x in it still. So what we're looking for is x equals some number. But in order to know what number x is, you first have to know what number x is. That's not helpful at all. That's like in English when your teacher's like, you can't use the word to define the word, right? You can't tell me what this means with using the same word that I'm trying to figure out what it means. That's not how, that doesn't work. That just leads us in a big circle. And so that's the problem with using square roots with this equation as it's written. When I have an x squared and an x, I'm not going to be able to use square roots because my solution will still be in terms of x. I didn't actually isolate the x to one side. It's still on both sides, and I still don't know what x is. So we can't solve by square roots for something in standard form written like this because we have x squared and x in the problem. When I have x squared and x, I can't use square roots as it's written. What I can do, though, is rewrite this thing so it looks like one of these quantity problems that we saw last time. So what we can do is rewrite this so that it's not in standard form, it's in vertex form. Okay, so what we're going to use is that completing the square process. Remember that this completing the square is how we change to vertex form. That's the name of that process, to change to vertex form. That's called completing the square. So I want to review that with you here with this first example, and then we'll talk about a little modification that we can do now that we're working with equations. So far, I really only looked at completing the square or changing to vertex form when I have an expression or a function. So remember, a function is something that looks like f of x equals or y equals. And in our last unit, everything had this format, right? We had y equals or f of x equals, and we just stayed on that one side of the equation. So to complete the square, to change this into vertex form, we said it should look like x in parentheses with something, and it's being squared. And the something was our b value, right? That coefficient for the x term, that b value cut in half. So 4 cut in half is 2. And then we kept the c that we had, but we had to make an adjustment, right? We had to subtract that cut in half number squared. So this would be minus 2 squared, which is 4. And then we tidied this up and we had x plus 2 squared minus 14, and we called that our vertex form. Now in this chapter, we're working with equations. That means I've got numbers on both sides of the equal sign, and we can move stuff across that equal sign, which we've seen already. We saw with our solving work in the last section. We can move stuff across that equal sign. So for our work today, and for most of the work that we do solving by completing the square or changing to vertex form, I'm going to stick with changing to vertex form the same way we did in our last unit, just for the consistency. That way I'm not mixing things up on you guys. But I do want to show you another approach that you can see to this, especially if you look at like the Delta Math or the Khan Academy help videos. I want to show you another option that you have, okay? So the other thing I can do is take advantage of the fact that I've got an equation here and I can work on both sides of the equation. So what I can do here is actually take this c value and move it to the other side. And I get x squared plus 4x equals 10. And then we're still going to rewrite this part the same way that we did before. So I'll have x in parentheses with something squared. I still finish out my quantity here by identifying that b value and cutting it in half. Okay. And then we've still got the 10 on the other side. But remember, the reason that we subtract that cut in half number squared here is because, and we looked at this in our last unit, when I write x plus 2 squared, that means x plus 2 times x plus 2. So when we distribute, if I take a look at what I've got here, I have x squared plus 2x plus 2x plus 4, right? This 4 wasn't in my original problem. So what I have on this side is this extra 4. When we were all on the same side, we accounted for that by then subtracting it, right? I added it, so I subtracted it to keep it the same. What we can do to keep it the same when we use both sides of the equation, since I added an extra 4 here, we add an extra 4 here. Okay, so that's a little adjustment, a little modification if you want to work on both sides of the equation. So we would get x plus 2 squared equals 14. Now I want to point out, I'm going to stick with this for today, that version that we're used to. But if I set it up just like my other problem and I kept everything on the same side, my next step would be move the 14 to the other side. And I end up in exactly the same place, right? These are the same. So this isn't doing anything different. I put the work in different spots because I'm using both sides of the equation, but they are the same. Again, for today, I'm going to stick with what we learned when we were finding vertex form, okay? But I wanted you to be aware that your work could look different on these. Questions for me so far? Okay, so let's take a look at a couple examples. We're going to change to vertex form and then use square roots to solve, okay? So down at the bottom here, the bottom of page 7, this is the same problem that was at the top of page 7. So we're going to change it to vertex form and then use square roots to solve for x. So if I want to change this to vertex form, I know I should have x in parentheses with something squared. My something is going to be that b value cut in half, so I have to find that coefficient for my x term and cut it in half. 10 cut in half would be 5. And then we keep the c that we have. And then we have to subtract our cut in half number squared. So 5 squared would be 25. Now I'm going to tidy this up. I have x plus 5 squared. And then this would be minus 28 equals 0. I could have given you this last time, okay? This is the problem like what you looked at last time. So I'm gonna get the squared thing by itself. That means move this 28 to the other side. So we have x plus 5 squared equals 28. Now that the squared thing is by itself, take a square root on both sides. So we get x plus 5 equals plus or minus the square root of 28. Do we know the square root of 28? No, we know the square root of 25. And then the next biggest one would be 36. So we know 28 doesn't have a nice square root, but let's see if we can simplify. 28 would be what times what? 4 times 7. 7 is prime, but we could keep going with 4. So 4 would be 2 times 2. So I get a pair of 2s. That means I have a 2 that can come out of the root. The 7 doesn't have a buddy, so it stays under the root. So x plus 5 equals plus or minus 2 root 7. And then my last step here to get x by itself is to subtract 5 from both sides. So I get x equals negative 5 plus or minus 2 root 7. Now, last time when we got a number that came out to a nice square root, like when we had square root of 16, we had plus or minus 4. We split that up into 2 equations. X plus 5 equals 4 and x plus 5 equals negative 4. When this doesn't come out to a nice number, we're just going to leave it sort of chunked together, okay? Now, remember this is still 2 solutions, negative 5 plus 2 root 7 and negative 5 minus 2 root 7. Still 2 solutions, but since I can't actually take negative 5 and add it to 2 root 7 to get a nice number, we're going to leave it in this sort of bulky format here. Okay, so those are my 2 solutions. Questions for me so far? Okay, so before we move on, I want to point out that we haven't actually done anything new yet. Changing to vertex form was a last unit thing, so we've seen this before. Solving with square roots was a last lesson thing, so we've done this before too. So we haven't really done anything new yet. We just took 2 things we already knew how to do and put them together. Go ahead and turn the page for me. Let's look at another example. Okay, at the top of page 8, we've got another example here. I want you to notice this is a little bit different from anything that we've changed to vertex form so far, because I have a number in front of the x squared. I have a lead coefficient or an a value that's something other than 1. I only know how to complete the square if I have x squared, not if I've got 2x squared or 3x squared or 100x squared. So the first thing I need to do here is get this 3 out. And I noticed that 3 is actually a GCF for this problem. So I'm going to go ahead and factor out that 3. If I have a number in front of x squared, I got to get it out of there. So we're going to factor out 3 since it's a GCF. That would leave me with x squared minus 2x plus 4. And we're still equal to 0. And now in our last unit, when we were just swapping between function forms, we had to keep the 3 there because that gave us important information about the shape of our graph. But in this unit, our focus is not so much about the shape of the graph. It's about solving for x. What are the solutions to this function? That means that I don't actually need to keep this 3 hanging out in front, which is nice because the thing a lot of us struggled with those GCFs that we pulled out was remembering to put them in the solution at the end, right? So you factored it out here, you forgot to throw it in your final answer there. Since we're solving now and we're not just swapping function forms, what I'm going to do is go ahead and divide this out to the other side. I don't need it to hang out in front of here. It's not doing me any good there. So I'm just going to divide it to the other side. So it's gone from here. And I've got x squared minus 2x plus 4 equals 0 divided by 3, just 0. Okay, so we got that 3 out of there. Now I'm going to do this the same way I did the last problem. I'm going to change this to vertex form. So I know I want x in parentheses with something squared. Find my b value. and cut it in half. So -2 cut in half is -1. I keep my c, and then we subtract that cut in half number squared. So 1 squared is just 1. And then we're going to tidy this up a little bit. So I get x minus 1 squared, plus 3 equals 0. Now that I've got vertex form, we're going to get the squared thing by itself. So I have to move this 3 to the other side. We have x minus 1 squared equals -3. Now that I have the squared thing by itself, I can take a square root on both sides. And I get x minus 1 equals plus or minus the square root of -3. The last thing I need to do here is get x by itself. So we'll add 1 to both sides. I get x equals 1 plus or minus the square root of -3. Now, there should be something that like waves some flags at you here. Why is it no real solutions?
Because you can't square a negative number.
Yeah, so the thing that should jump out at you here is that we're taking the square root of -3. We talked about this last time. This was an example on page 6, I think, where we ended up with the square root of a negative number, okay? We're gonna worry more about simplifying this and what it means when we get to algebra 2. For algebra 1, I want you to show me all the work that you did to get here. And then when you see a square root of a negative number, you're gonna write no real solutions. Okay, so show me all your work. And then at the end, you say, that's the square root of a negative number. That's weird. No real solutions. Questions for me so far? Okay, I want you guys to try A. Try A. Another minute or so, and we'll take a look at this one. So I'm going to start by changing this to vertex form. I know it should look like x with something in parentheses squared. My b is negative 16, so I cut that in half and I get negative 8. I keep my c, and then we have to subtract our cut in half number squared. So 8 squared would be 64. As I tidy this up, I get x minus 8 squared plus 12. 76 minus 64 is 12. And now I can treat this as a square root problem. So I want to get the squared thing by itself. That means this 12 needs to go to the other side. So I have x minus 8 squared equals negative 12. Now I have the squared thing by itself, so I can take a square root on both sides. So I get x minus 8 equals plus or minus the square root of negative 12. Now, normally I would ask you to factor this and simplify, but since we're taking the square root of a negative, I'm not going to have you do that, okay? If this were positive 12, factor and simplify. If you're taking the square root of a negative number, just leave that negative number as it is, okay? In algebra 2, I'm going to make you factor it and simplify. For algebra 1, we can leave it as it is. And then finally, move the 8 to the other side to get x by itself. So we get x equals 8 plus or minus the square root of negative 12. And then what's the last thing I need to write here? No real solutions. No real solutions. Very good. Again, anytime you take the square root of a negative number, no real solution. Questions for me on A? Oh,
How do you know when you keep the number in the C?
This guy?
Yeah.
So I'm doing this the same way that we did last unit when we changed the vertex form, which means I always drag this down and I'm always going to subtract that cut in half number squared. Okay, last one together for today. I've got a number in front of x squared. So the first thing I'm going to do is pull it out as a GCF. So that would leave me with x squared plus 6x still equals 4. Now I'm going to divide that 2 to the other side. Get it out of there. So I'm left with x squared plus 6x equals 4 divided by 2 is 2. Now for this problem, we have something on the other side of the equal sign. That's okay. I'm still going to complete the square over here, still do that change the vertex form process on this side. So I would have x in parentheses with something squared. So take your b value, right, the coefficient for x, and cut it in half. 6 cut in half would be 3. And then we bring down the c. In this case, I don't see a c, so it's just 0. And then we subtract our cut in half number squared. So I'll subtract 9. Again, I'm working all on the same side, just like we're changing to vertex form in our last unit. If you want to work on both sides of the equation, that's fine. I'm doing this the same way we did last unit. Now I'm going to tidy this up a little bit. X plus 3 squared minus 9 equals 2. Now I want to get the squared thing by itself, so I have to move the 9 over. We're going to add 9 to both sides. I get x plus 3 squared equals 11. And now that I've got the squared thing by itself, we can take a square root on both sides. So we get x plus 3 equals plus or minus the square root of 11. Does 11 have a nice square root? Nope. Can I factor it to simplify? 11's prime, right? It's just 1 times 11. So that's as good as it's going to get. Yes. I have to subtract my cut in half number squared. So 3 squared is where I got the 9. Because I didn't see a constant term here, right? Like here we had 76. Here I don't have anything. So I just filled it in with a 0. The only thing I could be adding or subtracting and not have to write would be 0. So that's fine, it was 0. Anything else for me so far? These are good questions. Yes. So that will be my last step. Okay. So the last thing I want to do is get x by itself. So we move that 3 over and we get -3 plus or minus the square root of 11. Those are my solutions. Any other questions on B specifically or on today in general? Okay, so again, we didn't really do anything new today. We took two things we already learned how to do and put them together. So we changed to vertex form, something we already knew how to do, and then we solved with square roots, something we already learned how to do. Okay, so two old things to do a new thing. Tomorrow, we're going to do some more practice solving with square roots, both stuff that we have to rewrite like today and stuff that we don't have to rewrite. So we'll get some more practice with those different types of problems kind of mixed together.